Oceanography. Human interest in the sea dates back to ancient times. Since then, the sea has been seen as a source of resources, mainly food, through fishing and the collection of some types of algae. It has also served as a communication and transportation route, and more recently, as a source of exploitation to obtain resources such as oil. This fascination with the sea has been a constant throughout history. Today, the oceans are also explored in search of answers about the origin of the planet and of life itself. All these topics are covered by oceanography, the science that studies the various aspects of the seas, and which is divided into four main branches: physical, chemical, geological and biological oceanography. Physical oceanography deals with studying phenomena such as temperature, density, pressure, and salinity, as well as the general behavior of seas and oceans. On average, the concentration of salts in seawater is 35 grams per liter, although this value can vary. The predominant salt is sodium chloride. The salinity of the sea can change for various reasons. The entry of fresh water from rain and rivers, for example, dilutes the salinity. Rivers such as the Amazon, the Orinoco, and the Rio de la Plata in South America, or the Ganges and Brahmaputra in the Bay of Bengal, and the Zaire and Niger in the Gulf of Guinea, are examples of this influence. In addition, temperature also affects salinity. In tropical seas, where rainfall is scarce and high temperatures cause strong evaporation, salt levels are usually higher due to the action of the trade winds. In these cases, the Atlantic Ocean stands out for being the most saline, reaching a concentration of up to 37 grams per liter in these warm areas, while the Pacific Ocean is closer to the global average. The Red Sea is the sea with the highest salinity, surrounded by deserts and receiving very little fresh water. Their high temperatures contribute to a high level of evaporation, while rainfall is so scarce that in some periods it does not rain at all. The behavior of the oceans includes phenomena such as currents, tides and the propagation of different physical stimuli in the aquatic environment. Chemical oceanography studies the interactions of seawater with the atmosphere, coasts and the seabed, while geological oceanography delves into the formation and composition of the ocean floor. Beaufort scale, wind speed and its effects. 1. Calm, less than 1 km per hour. No wind movement. The sea surface is smooth, without waves. 2. Light breeze, 1 to 11 km per hour. The wind is weak, barely perceptible. Small waves begin to appear. 3. Moderate breeze, 12 to 19 km per hour. Waves form with crests that begin to break. 4. Fresh breeze, 20 to 26 km per hour. Waves become larger, with foamy crests. 5. Moderate wind, 29 to 38 km per hour. Waves lengthen and break with force. 6. Strong wind, 39 to 49 km per hour. Waves are large and foam is dispersed by the wind. 7. Very strong wind, 50 to 63 km per hour. Large waves with foamy crests and foam dispersion in the air. 8. Storm, 89 to 102 km per hour. Visibility is reduced due to spraying of water and foam in the air. Waves can obscure small boats. 9. Hurricane, over 117 km per hour. Massive, foamy waves. The force of the wind and waves seriously affects navigation and visibility at sea. Oceanography and ocean movements. Physical oceanography studies the currents and movements of water in the ocean, being fundamental to understanding marine dynamics. Biological oceanography examines marine life and its interrelation with the ocean environment, covering everything from plants to animals. Atolls are structures formed by coral reefs that surround submerged islands. These corals grow to form a ring around a central lagoon. This process is gradual and can take thousands of years. Sea movements. 1. Waves. These are generated by the wind and affect the surface up to about 10 meters deep. Near the coast, the waves lose speed due to friction with the seabed, which causes them to break and erode the coast. 2. Ground swell. Wave movement generated by distant storms, which affects the surface without the need for local wind. 3. Tsunamis, generated by earthquakes or underwater volcanic eruptions. These movements can produce large waves that cause devastation when they reach the coast. Geography and ocean phenomena. The gravitational pull of the sun and the moon affects the Earth's oceans, causing phenomena that sailors and scientists observe and study. Different scales are used to classify waves. The International Douglas Scale, for example, measures wave height and establishes a relationship between wind strength and sea state. This scale ranges from level 0, which represents a calm sea, to level 9, which indicates a very rough sea, with waves exceeding 10 meters in height. On the other hand, the Beaufort scale, which also takes wind into account, ranges from 0, calm sea, to the range of 12 to 17, which represents a hurricane. In addition to these, there are other ways to classify waves, considering factors such as their frequency and speed. Tides. Tides are another important phenomenon, the result of the joint influence of the moon and the sun on the seas. The gravitational pull of both stars creates a bulge in the water in the areas of the Earth that are aligned with them. Although the moon exerts a stronger pull than the sun, its position relative to the Earth and factors such as the Earth's rotation and local geographic conditions give rise to various tidal combinations. When the moon and the sun are aligned with the Earth, during the new moon and the full moon, the strongest tides occur, known as spring tides. The maximum point of a tide is called high tide, and its lowest point, low tide. On the coasts, these tidal oscillations can reach amplitudes of up to 18 meters. In some places, such as the Bird Island in Argentina or Mont Saint-Michel in France, these movements are very spectacular, transforming the landscape in a matter of hours. Marine currents. Marine currents are not only found on the surface of the ocean, but also in its depths, although deep currents are mainly detectable by temperature differences. Surface currents usually have a moderate speed of just a few kilometers per hour, although they can increase in narrow areas. These currents are strong enough to influence the navigation of ships. There are two main types of currents: coastal currents, which are usually influenced by local factors such as wind and tides, and general currents, which have a greater range. The latter are driven by the prevailing winds and differences in water density. They are further divided into cold and warm currents according to their origin. Cold currents, with more linear trajectories, move from the polar regions towards the equator, while warm currents circulate in the opposite direction, moving clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Both types of currents affect the climate of the areas they travel through. Cold currents often create cold and dry climates, such as the Atacama Desert in Chile and Peru, influenced by the Humboldt Current, or the coasts of Labrador in Canada, affected by the current of the same name. In contrast, warm currents raise the air temperature at high latitudes, which generates condensation and rain. Along the coasts, areas of cliffs and beaches alternate, as on the Spanish coast, where both elements combine in a spectacular landscape. Waves, currents, and Atlantic coasts. The Gulf Stream plays a crucial role in regulating the temperature of the European Atlantic coasts. There are different ways of classifying ocean currents. A basic classification includes 1. Ocean currents. These mainly affect the surface of the ocean and can move large masses of water thousands of kilometers away. 2. Tidal currents. These depend on the gravitational pull of the moon. 3. Density currents. These occur when there are two masses of water with different densities, allowing one to move over the other. 4. Turbidity currents. These are formed when large masses of mud slide along the ocean floor, mixing with the water. 5. Currents associated with swells and undertows. They usually reach significant speeds and generate variations in the coasts. Coasts. Beaches, which often extend along Atlantic coasts, are actually the continuation of coastal territories. Large quantities of sand accumulate in these areas, coming both from the oceans and from the erosion of the coast itself. Through a process of erosion, transport, and sedimentary deposition, the sea waves carry the sand there. Although waves generally reach the coast perpendicularly, which does not cause significant sand displacement, waves that arrive obliquely can drag sand and other debris, including organic matter and minerals resulting from the erosion of the cliffs. In these cases, finer particles, such as sand, can be transported over great distances by this type of wave action. The retreat of cliffs, the constant action of waves erodes the base of the cliffs, causing their destruction and disintegration. In areas protected from waves or where currents and tides are gentle, the effect of erosion is minimal. However, on steep coasts exposed to these agents, erosion can cause large sinkholes. This phenomenon can be twofold. The upper, less pronounced part is the result of spring tides, while the lower, more pronounced part corresponds to neap tides. Erosion does not act uniformly. The rocks that make up the cliffs have different degrees of hardness, which results in an uneven retreat and the formation of various geographical features.